Hello and welcome to another NGen Math 8 lesson by eMathInstruction. My name is Kirk Weiler and today we're going to be doing Unit 3, Lesson 6 on rotations in the coordinate plane. In the last lesson you saw how to rotate in the Euclidean plane where there were no coordinates, and what you needed to know was the center of rotation, the angle of rotation, and what direction you were rotating in, counterclockwise or clockwise. In this lesson it's going to be exactly the same thing with a few key differences. One of them being that you're going to be in the coordinate plane. So you're going to have points with XY coordinates. You're always going to be rotating about the origin. That's kind of nice. And you're always going to be rotating by either 90 degrees clockwise or 90 degrees counterclockwise. Now sometimes we might have you rotate 90 degrees and then another 90 degrees for a total of 180 degrees. But ultimately speaking, there will be no 40-degree rotations or 120-degree rotations or anything like that. It's either 90 clockwise, counterclockwise, or, a couple 90s in a row, So let's get right into it in the first exercise to see how we can rotate points in the coordinate plane. Here we go. All right, exercise number 1, rotating about the origin by 90 degrees. Here we go. On the grid below, 4 points have been plotted with coordinates of A, 6, 0, B, 0, 4, C, 0, -3, and D, -7, 0. Rotate each of the following points by 90 degrees counterclockwise about the origin, O. Point A has been done as an example. State the image coordinates below. All right, let's talk a little bit about point A, right? Point A we have here at 6, 0, right? We rotate it by 90 degrees and not surprisingly, it lands on the y-axis. Why? Because the x and the y-axis are at 90-degree angles to one another. That's sort of their whole point, right? Now, the other piece is not only does it land on the y-axis, but it lands on the y-axis the same distance away from the origin as what it began. Now, it began 6 units away on the x-axis, and it ends 6 units away on the y-axis, so it ends up at the point A prime 0, 6. Now, be careful, right? We already looked at some patterns that occurred with reflections. The last thing I'd want you to do is look at this pattern and go, oh, I get it. To rotate by 90 degrees about the origin, you just switch the x and the y coordinates, 6, 0, 0, 6. And there's definitely some patterns that occur with rotations by 90 degrees about the origin, but that's not the pattern, all right? Let's take a look at one more together and then have you do the last two on your own. So the second point, B, is at 0, 4, right? Sitting right there. We want to rotate that 90 degrees counterclockwise. So yet again, we know because it starts on the y-axis, it should end up on the x-axis. And since it starts 4 units away from the origin, it should land down here also 4 units from the origin, meaning that it should end up falling on the point B prime, -4, 0. All right, it's a beautifully large comma. Okay, what I'd like you to do now, pause the video, take just a little while to figure out where C and D go when you rotate them 90 degrees counterclockwise about the origin. All right, let's go through them. Here we've got letter C. It's down here at 0, -3. When I rotate it 90 degrees about the origin, it's going to land right there at 3, 0. Right? So we come up like this. We get to the point 3, 0. Letter D, which is at -7, 0, when rotated 90 degrees counterclockwise, will be at D prime 0, -7. All right, that's pretty easy. Now, let's see if you've got the right idea by taking a look at problem number 2. All right, point E has coordinates E, 0, -5, and was rotated by 90 degrees clockwise about the origin. What would be the coordinates of its image, E prime? All right, so I'd like you to take a shot at this. Just keep in mind, we're now rotating point E by 90 degrees clockwise about the origin. So see if you can figure out where its image lies. All right, here we go. So we've got point E, which is at 0, -5. Let's plot that. Now, it's on the y-axis, and when I rotate it 90 degrees clockwise, it will end up being on the x-axis again, the same distance away that it started. It started 5 units away. It'll end up 5 units away, and specifically at E prime -5, 0. Let me label that on my image. All right, that's it. Now we have to attack the trickier part, which is what happens when we rotate about points, or we rotate points that aren't just sitting on those axes. So let's get into that next. Right? One of the things that made the last problem easy is that all the pre-image points either started on the x or the y-axis, so when we rotated them by 90 degrees, they ended up on the other axis. So if they started on the y-axis and we rotated 90 degrees, they ended up on the x-axis and vice versa. But now we're going to take a look, starting with the point at A, 3, 7, and we're going to see what happens when we rotate that point by 90 degrees in either direction. So let's take a look at exercise number 3. The point A, 3, 7, is plotted on the grid shown. It has been connected to the origin by a segment for visualization purposes. By rotating your paper, that's right, we're going to actually rotate the paper. By rotating the paper, find, letter A, the image of A after a rotation by 90 degrees clockwise, plot and label as A prime, connect to the original with a segment. All right, so it's this simple. I want to take this point and I want to figure out where it ends up after a 90 degrees clockwise rotation. So what I'm going to do is I'm going to just take my paper right now and I'm going to rotate it 90 degrees clockwise. That is absolutely it. Now, once I've rotated it 90 degrees clockwise, I want to treat this as the x-axis and this is the y-axis, and I want to just read off the coordinates of this point. Well, that would make me go 7 units to the right and 3 units down. 7 to the right and 3 units down. So my image point, A prime, is going to be at 7, -3. All right. Now I'm going to rotate my axis back up, back to where it started, and I'm going to plot that point, 7, -3. And I want to connect it with a line segment. Now I want to be very clear about both the line segment that connects the origin to A and the one that connects to A prime. Those line segments are normally not there. They're certainly not required. The reason that I like to have them in is that it really kind of helps you to see that 90-degree angle, right? If we had actually botched where that image point was and we kind of drew the 2 segments in, we would see that that didn't look like a 90-degree angle, you know. But they aren't necessary, the segments that is. Now, let's take a look at letter B. The image of A after a rotation by 90 degrees counterclockwise. Plot and label as A double prime, connect. All right, so same thing. Now I want to take this thing and I want to rotate it by 90 degrees counterclockwise. Now, one of the weird things is that this segment and A prime and even that little right angle symbol, they're not going to move as I rotate my paper. Normally they would, right, on your paper. But this time what I'm going to do is I'm going to rotate this thing 90 degrees counterclockwise, or I'm going to try. And now I'm going to read off the coordinates, again, pretending this is the x and the y-axis. That's going to be at -7, +3. -7, +3. Let me just rotate that back so we've got it where we want it. And that's going to be A double prime at -7, +3. There's my A double prime. I can now connect that with the segment. And again, the segments really truly aren't necessary. I just want to see that 90-degree angle. Notice it isn't a coincidence that A prime and A double prime are 180 degrees away from each other, given that these are both 90-degree rotations. That's it though. That's actually the way we're going to rotate points 90 degrees either clockwise or counterclockwise by simply turning our paper. It's that easy. Let's get some practice with it in the next exercise. Here we go, exercise number 4. For each point below, find its image point after the specified rotation about the origin. Plot the original, pre-image, and image point on the grid. All right, so let's do it. So letter A, let's do this one together and we'll have you do B and C on your own. Letter A says rotate 7, 2 by 90 degrees counterclockwise. So the first thing I'm going to do is simply plot point A. So 7, 2 is sitting right here. All right. Now I want to know, where does it go after a 90-degree turn counterclockwise? So I take my paper and I simply turn it by 90 degrees. Now that point really should have gone with it, but it didn't, which makes a lot of sense because why would it? And it would end up being right here. All right. So that would be where A prime would end up being. And in fact, it would be at -2, +7. -2, +7. Again, much easier for you than me. -2, +7. It would be right there. All right. What I'd like you to do now is I'd like you to take -3, -8 and rotate it 90 degrees clockwise. See where it goes. And maybe the hardest one, but I'm going to let you play around with this on your own, 4, 6, rotate it by 180 degrees in either direction. And we'll talk about why it doesn't matter which direction I specify in a bit. Pause the video now and work through letter B and letter C. All right, -3, -8. All right, so -3, -8 is going to be right down here. That's going to be letter B. Now, what I want to do is I want to rotate my entire sheet by 90 degrees clockwise, and I really kind of want this point to come along with it. Unfortunately, I can't really do that, or maybe I can. Actually, let me try something really quick. All right, on the fly. Here we go. That's going to work. So now I've got that thing at -3, -8. I'm going to click on this. I'm going to try to rotate it. There we go. Now it rotated properly, right? So my new image is now going to be at -8, +3. So B prime is at -8, +3. So let me just rotate that thing back. Oh my goodness. This is pure chaos now. -8, +3. Oh, and B moved where it was. That's at -3, -8. Pure chaos. All right, let's talk about the point 4, 6, right? So 4, 6, my pre-image point C is right there. I may try to group these things together again just so that you see it. And I need to rotate it 180 degrees in either direction. The plain fact is it doesn't matter. Whether you rotate 180 degrees clockwise or 180 degrees counterclockwise, you end up in the same location because you're talking about a half turn, right? If I'm standing right here and I turn 180 degrees, and that from my perspective was counterclockwise, that's going to do exactly the same thing as if I turn 180 degrees clockwise, right? Either way, you end up looking at my back. So, in terms of C, what I want to do to rotate it, and again, I'm going to try to group all of these together except for hopefully the eMathInstruction icon. Let me try it again. I'm going to group all of these things together so that the points sort of rotate with it. I don't know how they ungrouped last time, but if I rotate 90 degrees counterclockwise, one turn, and then another 90 degrees counterclockwise, another turn, then I've rotated 180 degrees. And where my new C is at -4, -6. -4, -6. Now, hopefully, unlike the last time, I'm going to bring this back up. And I find C prime is at -4, -6. Sorry if some of these points aren't exactly where they're supposed to be, since we had a little bit of an issue with the technology. But it really is pretty much that simple. If you have to rotate 180 degrees, rotate 90 degrees, and then another 90 degrees, and you will in total have rotated 180. All right, let's keep moving on a little bit. Let's take a look at our last exercise, exercise number 5. Triangle ABC is shown below, has vertices at A, 3, 2, B, 5, 7, and C, 9, 2. Letter A asks us to draw a triangle A', B', C', the image of ABC, after a 90-degree counterclockwise rotation about the origin. State the coordinates of its vertices below. All right, well, here's a suggestion for you. I would suggest turning the paper 90 degrees counterclockwise, coming up with all the coordinates, writing them down, and then plotting them to see what that triangle looks like. Pause the video now and go ahead and rotate that triangle. All right, here we go. So I want to rotate this thing 90 degrees counterclockwise about the origin. So I turn my paper 90 degrees, and I'm all set. Now I'm going to read off the coordinate points, right? So now A' is going to be at -2, 3, right here. B' is going to be right here. It's going to be at -7, +5. And C' right here is going to be at -2, 9. Now once I have those, then I just kind of rotate my figure back. I erase all this random circling, and I get -2, 3. That's going to be my A'. B', -7, 5. And C', -2, 9. And connect them with straight line segments. And there we have it, right? So A', B', C' is the rotation of ABC 90 degrees counterclockwise. Now letter B asks us to draw triangle A', B', C', the image of A', B', C', after a reflection in the x-axis. State the coordinates of its vertices below. All right, so now we just want you to take this triangle and reflect it across the x-axis. Go ahead and do that and figure out what the coordinates of its vertices are. Take a few minutes to do this. Pause the video now and remember what you've already learned about reflections. All right, let's do it. So, easy enough, right? A', which is at -2, 3, when we flip it over, will be at -2, -3. Right? So there's our A'. And this is very common where you're going to be asked to do one thing to the image, and then you're going to take, to the pre-image, then you're going to take that image and do something else with it. So now B', it used to be at -7, 5. It will be now at -7, -5. So it'll be right here. B', and finally C'. C' is at -2, 9. So now we're going to have -2, -9. And our triangle. Great. And there it is, right? Now again, the whole idea here is very, very simple, right? The whole idea is that, we're now doing what's called composing transformations. I take an object and I rotate it. Then I reflect it, right? And this is always what's going on when you've got an image on a television screen or your phone, like you take a picture on your phone and then maybe you flip it or you rotate it or something like that. This is the math that's allowing your phone to do stuff like that, which is really rather cool. All right, let's wrap it up. So today, what we saw was rotating in the coordinate plane. And just like rotations in the Euclidean plane, we needed a center. In this case, it was the origin. We needed a direction of rotation, clockwise or counterclockwise, and we needed to know an angle of rotation. In the coordinate plane, those angles will simply be 90, 180, possibly 270, right? They will always be quarter turn increments. And we figured out where points went by simply rotating our paper, reading off the new coordinate point, rotating the paper back, and plotting it. It's really pretty easy as long as you know your counterclockwise from clockwise. And that can be tricky for some, it really can. So get some good practice on it on the homework. For now, I just want to thank you for joining me for another NGen Math 8 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.